In this video, we're going to apply a /27 subnet mask to an IPv4 address and identify what happens to the size of the network. We're going to use the same object address that we've been using, 192.168.100.10. And in this case, the subnet mask is going to be a /27 or a 255, 255, 255, 224. Once again, where did 224 come from? The first three digits of the fourth octet are now licensed for network. They're no longer hosts. So if we added 128 plus 64 plus 32, we'd get 224. That's where that number comes from. And so our line that we're going to draw, or the space that we're going to use, is now going to be separated in this way. So how many bits do we now have left for host? Not that many. We only have 5. So that's 2 to the 5th power. That's 2 to the 5th power. And if we look at that and we take that into consideration, we're going to come up with that's going to be 32. So that's 32 addresses per subnet is what we're going to create. 10 happens to fit into that very first one. So if we looked at the last 5 digits and we said, okay, 0, 0, 0, 0, 0, those 5 digits would be equal to 0. And if we took the last 5 digits and put them as all ones, that'd be 16 plus 8 plus 4 plus 2 plus 1. That would be 31, and we'd have a network that would be between 0 and 31. Now, that being the case, that's only the network that has 3 zeros for the network positions, right? So if we were to draw in, the first 3 digits here of that octet, whoops, hey, that was supposed to change. Let's try that again. Now it's red, and red, and red, and red, and red, and red. Those are 3 zeros in the first part of that octet. We now care what those are. And in this case, there are 3 zeros. So the number 10 here is going to be between that first network. It's going to be between 0 and 31. So network ID with a /27 for 192.168.100.10 is going to be 0, 192.168.100.0. Broadcast ID for this particular mask is going to be 192.168.100.31. That would be the last possible address in that particular space. We'll do the same thing we did previously, but I'm not going to write them all out because there's 8 of them, and that's just like way too many. But what if the binary combinations started at 001, or if they started at 010, or if they started at 011? What would those binary combinations look like if we were to find the network IDs for each one of those? I'm going to go ahead and go back to the drawing utility and pick my other pen and say, okay, well, if this was 1, 2, 3, 4, 5 zeros, the next network ID would be 32. The next network ID would be 32. The one following that would be 0, 0, 0, 0, 0, would be 64. And the one following that would be 32 plus 64, which would be 96. 0, 0, 0, 0, 0. So what I'm doing here now is just writing out the network IDs for the next 3 networks. So there'd be a network that would start at 0, a network that would start at 32, another one that would start at 64, another one that would start at 96. I hope I didn't confuse you from what we did previously, where we were doing the network ID and the broadcast ID. But the broadcast ID can easily be found by just removing one number from the next network ID. So 32 to 63, 64 to 95, 96 to 127. And the following networks would start at 128, 160, 191, 224, and we're at the end. We've got them all. So keep that in mind. So hopefully this is making sense. What you should be noticing if you're watching these videos in sequence is that the size of the network is getting cut in half each time, and sooner or later they're going to get so small that the number 10 is not going to have a network ID of 0. But that didn't happen yet. So we went from 0 to 255, and then 0 to 127, and then 0 to 63, and in this one, the network that 10 happens to fall in is 0 to 31. Think about, before you watch the next video, think about the size of what you think the next network is going to be. So when we do that /28 video, think about what you think the answer is going to be for that network, and we'll work that one out as well.